I'll tell you some things about server-side apply and what we learned from that, and a small library that we built called Boxcutter. I'm Josh. I work as a site reliability engineer at Red Hat's hybrid cloud management team, where we operate stuff on top of managed OpenShift. We originally planned to have Nico here as well, but he unfortunately fell sick and is staying at the hotel, and I'll take over his part of the talk as well. So bear with me if I don't get it like 100% correctly. Yeah. So server-side apply, the holy grail. But why is it the holy grail, and what was there before? Like before server-side apply, most controllers would, or most general kube clients would work in a way where they would read an object, modify some values on the object, and then write that back to the API. But if you have two or more clients doing that in parallel with no locking, then you risk overriding each other's data. So in Kubernetes, there is a concept called optimistic locking. Whenever you read an object from the API that already exists, there is an opaque value called resource version in it, and you have to pass it back when you do the update to replace the object. And when some other actor in the system does the same in parallel and changes it, then your update will fail. So here there are like two clients in parallel reading, modifying, and updating an object, the same config map, with different values, so they wouldn't even like overwrite each other's data. But one of these will fail. One of these, if you run those in parallel, one of these will be very unhappy and the other one will be very happy. And as I already said, it's based on the resource version that is an internal etcd counter that is monotonically increasing, and it basically is supplied by the API server to etcd on upgrade, and whenever that value has changed in the meantime, etcd will just reject the write operation directly. So you can be sure that you never, ever override values that were written in the meantime that you didn't know about. The thing is, there are some pros and cons to this approach. Pros is, it's very easy, like if you go back, it's very easy to implement. You just read, modify, update. You don't have to have like some complex apply logic or patch logic that computes what you want to change about the object. You just do that. It's very easy. And you don't overwrite data. It does also have some drawbacks. Like, there is no real story, built-in story about multiple actors handling only parts of objects and like having conflict handling on fields of objects only. You imagine if this config map has like 10 different actors in the system, all trying to manage and update this config map a lot, then you have a lot of retries in the system, because whenever one of these calls failed, your controller will basically back off and you probably will retry the same operation again, because you can like order the same operations sequentially, no problem, but you have to retry, and then like if you have multiple actors, they'll have to retry until they eventually get a full read, modify, write cycle in which no one else interfered by actually getting their write through as well. And if you use a language like Go, where you serialize the data of the object into a Go representation, then, and you don't know about all of the fields in your Go representation, then you can lose data when you reserialize. Like, if my Go type wouldn't know about the data field of a config map, and I would serialize it into Go, or deserialize it into Go, then I would read all the other data, like the metadata, and that would be fine. And then I would modify something, and then I would write the object back. but I would also forget about writing the data back. So that's not too good. Declarative approaches rescue you, though. With server-side apply, each actor can basically only specify whatever they are interested in a config map. Like the same two clients that I showed you earlier, instead of like having to read the full object and having to write back the full object with all the other changes of all the other data of all the other actors in the system in it, they just specify, I want only this, I only care about this data key in this config map. And I'm the other actor, I only care about this key in the config map. And the API server will take care of merging that together here into a single object. And it will actually keep track who owns which field for you. And nice thing is order doesn't really matter. You can just like act on it whenever you want. You mostly only will have to fire one request into the system to get this in. So all is happy and harmonic. The field ownership stuff is tracked inside of the API. So each of these actors in the system specifies their name and supplies it to the API as a field manager name. And then the API server tracks which field is owned by which actor in the system. Like for example, from the example before, the first actor owns the logging field inside of the data field inside of this config map. And you can even see this was added by an apply operation and at that time. And the other actor has the same information about his field. Whenever more than one actor tries to act on the same field, there will be a conflict. And the API server will just reject that by default. So here, there is no conflict because each actor in the system has their own field. But if both wanted to work on like the logging key, for example, then the API server would just say, nope, this is owned by some other actor in the system. This is the actor. This is the field that you conflicted on. You can look at all of this by basically doing kubectl get and passing show managed field to it. And then it will include this data. Normally, it will hide it from you because it tends to be very, very verbose. To cope with those conflicts, clients basically have three different strategies. One is you just say, I don't care. I will overwrite whatever was there in the field before, and I will take ownership. So if I specify a field and it is already in the system owned by another actor, and I specify I want to force override this, I want to force conflicts, then I will take over this value, and the system will now also track that I have become the new owner. Most controllers will work like that. Like, for example, a replica set controller that owns pods, it will want to just force the values into the pod object. You can also basically give up your claim on that field. Like, for example, imagine your controller or your client wants to add multiple fields to an object, but one of those is already owned by another actor in the system. And you're like, fine, that's fine. You can have this field. Then I'll just retry again and not specify this field, and that's managed by you. Wait, this is the flow that I just explained. Then the conflicting field will still get owned or still stay owned by the other actor, and I only own the new fields that I added. And then there is the third one, where I basically say, I'm fine with whatever is in the field right now, but I also want to own it. So in case the other actor goes away and doesn't own it anymore, then deletion doesn't happen. Yeah. So when I want to get rid of data that I put in the system, like for example, I previously specified 2 fields, and I want one of them to go away, I just shoot another apply request into the system where I don't specify that field anymore, and the API server will realize through the tracking that I showed you earlier that I want this field that I'm not specifying anymore to go away, so it will be deleted. And to prevent that, I just messed up the order. No, I actually messed up the slides. I'm sorry. Yeah. Yeah, so deletion can be prevented by basically taking shared ownership of fields in the system. That is what I said earlier, where you retry again with the value that is currently in the field. And to give up all claims of your object or of all fields in the object, you can also shoot an empty request where you just specify the object metadata, and then everything that you previously owned will be deleted, and you give up all claims on the object. So far, so server-side apply. Since this talk is not only about me like rambling about server-side apply, but also about the things that we learned, I'll tell you some things about very, very stubborn controllers in the system. Like, imagine a war between 2 controllers that are very, very stupid, where both of them just want to own an object fully. You'll have a controller A forcing the ownership of an object, but you also have a controller B who does the same thing. What happens? What is the result of that being in the system? Your cluster blows up. Your Cube API server dies, your etcd just explodes and dies. And worse, someone has to clean that mess up, right? Someone who SREs or supports that cluster has to clean that up and has to jump in. So there might be some client-side throttling that will help you with that a little bit. There is no API server throttling really in place in Cube. There might be some client-side throttling, but that doesn't help you too much, especially if like something bad happens, like one of the controllers crash looping and then in its sequence does this call, and then it just crash loops again and again and again, and they just fight. So what do? You let the stupid win. You just let it explode and let it happen, but you know their address. You know who did that because you know which fields are tracked by the competing controller. So at least you know where to look in the system, and you don't have to start like looking at Cube server audit logs or something that is like very noisy and like very hard to keep track. Yeah? Yes. Yes. Yeah. Some will forget to change or set their control, or will basically just shell out to kubectl apply, as you said. And then kubectl edit or kubectl apply will be the field owner, which is tricky in itself. But it's at least some hint to go and look. And ideally, like if you control one of those controllers in a system, and you think, obviously, you think like whatever controller you're operating, yours is right, then you can take that information and log it or report it up the stack somewhere. So someone will know there was a conflict, and maybe your controller can even actually start backing off slowly. Yeah, so another story that we learned, or another thing that we learned, status reporting in Cube, or statuses in general. It is very, very, very important to look at all parts of the status in an object. Like, for example, in a deployment, you have an available condition, and that can be status true because the deployment was like fully available. But actually, but actually, if you look further into the status, you see that only 4 of the 6 replicas in the deployment are actually in the latest desired state. So available, like just look at all of the data you have there. Or for example, CRDs, it's not enough to just apply them into the system and have those objects be in the system. They have to actually be established. We learned that the hard way once because we were not looking at our dependencies good enough, and then a controller or a code generator updated and changed their pluralization rules. So one of our CRDs now had a different plural name than before. And when it was upgraded, or when it was established, or not established, when we upgraded our controller, it conflicted with the previous version of that CRD in the system. And we were lucky because we were actually looking at this established condition and were waiting for other operations in the system to proceed until that happened. So we were just blocked in the upgrade, but we didn't like do anything that then needed this new CRD to be in place 100%. And we found out really quick. Make sure that your status is up to date. Like most of the status fields, most of the objects with a status subresource in Cube have a field called observed generation in the status, and many of those also have an observed generation in the individual conditions of the object. And each object in Kubernetes has a generation that each object that has a spec and the status has a generation that monotonically is counted up and thus invalidates the status whenever your spec changes. Like imagine a deployment, you add a new image to the spec, and then all of the status that currently belongs to that deployment is not valid anymore because it's not reflecting the newest thing that you just specified. You actually have to wait until the deployment controller updated the replica set or created a new replica set, rolled over to the new deployment, rolled out new pods that you specified as part of your deployment, and then you'll see the updated, the observed generation be reported the same as the generation of the object in one point in the future. Like with deployments, it's not that complicated normally because if the deployment controller is not working, that means the Cube controller manager is not working, and you know that really fast because your cluster will not work anymore. But for operators that operate on custom resources, that operator could be down. So what happens, like you'll want to know that whatever you modified in spec was never picked up by any system, by any actor in the system. That is how you figure that out. I didn't fully get that. Okay, I gotcha. So the question is, I'll just repeat this for the recording. The question is if an object has multiple controllers operating on it and writing statuses or parts of the status, what the handling of observed generation would be there. All of this is up to the author of the CRD. So you probably would not have a top-level observed generation, but instead you would like have multiple different sections of your status and multiple observed generations for these sections. And then each of the controllers, like for example, if I have one controller that, like, let's just assume we have controllers that do not really care about status fields directly, but only about conditions. Each of the conditions has its own observed generation. And then each of the controllers just takes care of the observed generation fields that it actually writes the status for. Yeah, so the general lesson here is just because status is there, it absolutely doesn't mean that it is up to date. You have to check and ideally poke the operators or the authors of the CRDs that you're using to include this kind of status invalidation in their APIs. Another big thing that we learned is ordering of operations. Like normally in Cube, you don't really have to order your operations, right? You just fire a bunch of objects into the API and they will eventually be consistent. Like you can you can just roll out multiple things in parallel and at the same time apply the RBAC and service account permissions for these workloads into your cluster and a service that will route traffic to these workloads inside of the cluster, and that will work out. But it can prevent a lot of errors and a lot of unpredictability if you order your operations. Like for example, some requirements just have to be met. You have to have a namespace there to be able to put objects inside of it. You have to have the CRD established before you can create CRs belonging to that CRD. Sometimes it's also nice to just wait for the status of a thing to be reported or to stabilize. Like for example, if you have a workload that is not crash looping, but it comes up, and then at one point it receives its first user request, like when the readiness probe becomes available, and then it receives its first request from the customer, and then it just dies because of a nil pointer dereference or something. You can order, like if you write a controller that orchestrates all of that stuff, you can just sleep for a little bit and then probe again and make sure that your workloads actually have stabilized. This, like ordering in general, makes your operator more predictable. We have a lot of workloads in my team where we care about first rolling out CRDs and then rolling out the deployments that operate on these CRDs, so you won't have a crash looping operator that looks for an API that isn't in the cluster yet. And also, the nice thing is, with ordering, it makes it able that it gives you the ability to think about tear down and deletion. You can do the same thing, the same ordering in reverse. Like very often, if you SRE stuff and you delete the whole stack, you will get monitoring errors because your pods are already gone, but your PROM still tries to scrape those pods. But if you have the ordering set up in a way that you first you roll out your workload, then you expose it to the cluster, and then you add your service monitor, when that thing has fully stabilized, you will have like good metrics that are not like failing at the boot of the component, and also the other way around. You first remove the service monitor, and then PROM stops scraping your workload, and then you will slowly tear down the workload. That makes like being on call and having pages and alerts for those things a lot more predictable and easy. Yeah. All of these learnings and the server-side apply flow, we implemented in a library called Boxcutter that is available on GitHub. We extracted most of those learnings from package operator, where we use those things and where we, like all of the use cases that I told you about are basically part of package operator already. And both of these projects, package operator and OLM v1, which is not the current OLM that you all know, but the newest release of OLM that has different APIs, are migrating to this library to implement all the learnings and all the good stuff that we put there. Yeah. That's basically it from my side. Do you all have any questions? Yeah? All of the examples that directly use a client, the code examples at the start of the talk and later, the one with the fighting controllers that actually use server-side apply, use the controller runtimes client. So that is sorted out in the library. Sorry, I forgot to repeat your question. So the question was, or the initial statement before the question was that at some point there was a problem with controller runtime and server-side apply, and where you were not able to use it. And if that is still the case, and if Boxcutter does some dance around that problem, and the answer is no. Controller runtimes client exposes server-side apply to you transparently. You can use it. You're welcome. No other questions? Cool.